Okay, so the last topic for today would be segment anything model. Okay, so segment anything SAM for short is a fully automatic promptable image segmentation model. So this is a very important term, a promptable image segmentation model. The previous type of image segmentation models are not promptable. So take for example the mask CNN, the unit, the deep lab or FCN. They are all either a CNN based or a transformer based deep learning image segmentation models. Okay, and they are trained on a specific dataset with a specific task. Okay. Now SAM is a different class of segmentation model. It's considered as one of the foundational computer vision models, which means it is trained on a huge, enormous data set, and it is not trained to do any specific task. That is one thing. Second, it is also trained in a specialized manner, in a specialized fashion, so that you can use the SAM model in a similar way you use your ChatGPTs or Claude or Gemini. So how you use ChatGPT, Gemini or Claude? You ask some questions to the LLMs. That is basically the brain of all these ChatGPTs and Geminis. And those questions are nothing, a technical term for them is called prompt. So you prompt an LLM and the LLM takes those prompts and process them and understand what is your intention. What are you trying to ask? And then it understands the context and then it generates an output. That is why it is also called as generative models or generative AI. Now the SAM also takes a prompt, similarly how you prompt your ChatGPT. But these prompts are not any questions or any sort of instructions. These are prompts in form of bounding boxes, mouse clicks, and then it could also do text recently with SAM 3, but with SAM 1, it was still not able to do process a text prompt. It was able to do a bounding box prompt and a clicks. Okay. And it takes a prompt and then it can generate a precise bounding box of those objects, right? As you see in this quick animations, wherever you click the mouse, it just segments those objects, right? So there is a turtle and on top of that there is a frog, on top of that there is a snail. So you could, when the mouse is hover over the turtle, it could also separate between the water reflection of the turtle and the turtle above the water. That also it can differentiate. It can also differentiate the frog from the turtle. It can also differentiate the snail from the frog, right? So this is what is a promptable segmentation model is means. Okay. And also we were talking a lot about annotations. So this SAM actually help to lessen the burden of annotations, and particularly if you want to train any segmentation models, it takes several orders of magnitudes of efforts in labeling a mask than you want to label a bounding box, because in bounding box you just draw a rectangle, but for segmentation you need to precisely trace the boundary of the object and draw a polygon or a mask. So that takes a lot of time, and Sam actually made it like 10 times or even more faster. So with this kind of tool, any object can be segmented. All you need is to prompt it in the right way. Okay, so instead of taking 2-3 minutes to draw a precise box, all you need is to just click on that object and you will get the box automatically. I demonstrated in the open CBAT tool, right? Instead of drawing a precise boundary around the person who was walking, I just draw a bounding box around it and it was giving the segmentation mask instantly. And that only we will. Yeah, that is what the internals of those SAM model, which we will look into it. So how SAM model works, what he's asking is how, when you give a bounding box, how it predicts a mask. And that's basically the internals of the SAM model, which is described in this slide. Let's see how SAM works. So SAM has like 4 main steps. The first step is the image encoding. Second is prompt encoding. Then we combine the image encode with the prompt encoding. Then we do a mask prediction of it. Okay. So here is a high level architecture diagram. So we have an input image. It passes through an image encoder. So this image encoder is similar to some OpenAI clip kind of model. Okay. We'll also see the block and the paper, but just imagine that there is an image, then there is an image encoder. From the image encoder, we'll get image embeddings, right? Then what we have prompt. So the prompt can be just a mouse click point, which means we just have an X, Y. Then we have bounding box such as X1, Y1, X2, Y2. And it was originally intended to support text prompt as also, but until SAM 3, it was not able to do. It was in the development process. Only in SAM 3, they were able to achieve this text prompt. Um, then what they do, they have a lot of uh, training data. Okay, so here also, if you see, now the SAM model is being released as an open source, and now we are using it to accelerate the labeling. But in order to create a SAM model, can you skip the data labeling? No. They have used some data set of a billion images with billion masks, and the paper also addresses how they created this data set. Okay, it's not always about the models. There is also a significant, almost 50% of building these kind of models, SAM or GPTs, 50% or even more is to build the data set itself, right? So you need to probably OpenAI would have hired a lot of guys to actually generate these data. So that's why, like, first what they did, they didn't go straight from 0 to 1 billion just in one go. So they first labeled, let's say, lakhs of images with hiring 1,000 labelers. Then they trained one model. Then they used that model to label rest of the 99 lakh images. Okay, not probably 99 lakh. They might have used to let's say, another 10 lakh images. Then they evaluated that. Probably out of the 10 lakh, 8 lakh would be correct, 2 lakh would be wrong. So they have to remove that. Then they fine-tuned the model. Then using that model, they would have predicted the labels of the remaining. So they have to go all these cycles of predicting, reviewing, correcting on all those things until they build a reliable data set. And once they build a reliable data set, then they do a full cycle of training. Then you have a SAM model. So the SAM model will not come just out of nowhere, but you have to go through step by step. Right. So this is basically an architecture, but during inference, this is what will happen. See, it has a two-step actually. One is creating the image encoding. Okay, that is basically the time-consuming step of these SAM. But let's say once the image embedding is created, creating the mask through from the prompt is very instant. So the image encoding will probably take 2 seconds, 3 seconds, or 4 seconds, depending on your hardware. But getting a mask from a prompt will be less than half a second. Okay. So, so this was the SAM original blog that was released by Meta like 2 years back, right? So this is indeed a game-changing model, actually. Okay. So similar to ChatGPT moment that happened in November 2022 for the text domain. This was one of those ChatGPT moments for images. Okay. As you can see, they have clearly told working towards the first foundation model for image segmentation. Okay. And see here, they have created a segment anything 1 billion mask data set. Okay. So the ham has been trained on 1 billion images with its corresponding mask. Now, if you look at the paper, they would have described a lot in detail how they created this SA1B dataset. So that's why I said, like, this is not always model training and evaluation. There's a data is a lot more important than your model. So there is a one data engine. So to achieve a strong generalization to new data distribution, we found it necessary to train SAM on large and diverse set of masks before any segmentation dataset that already exists. While a typical approach for foundation model is to obtain data online, masks are not naturally abundant and thus we need an alternative strategy. Our solution is to build a data engine. Okay. So similar approach you can found in Andre Karpathy's talk in his 2022 Tesla AI Day talk. Similar, see, if for segment anything, nobody's life is at risk. Okay. If they are building a comprehensive data engine for an open source models, which is just released for anybody to use on any use case, and they are not liable for anyone's life. Being Tesla, putting an autopilot mode or a fully autonomous self-driving mode, just imagine what would be the type of data engine they have to build. Probably it is 100 times more than what SAM 1 billion data set has built. Okay. So we co-develop a model with model in the loop data set. Okay, which means that our data engine has 3 stages. First, they start with assisted manual, and then they go for a semi-automatic, and they go for a fully automatic. Can I go straight to the 1 crore question? I'm not sure. So you always have to answer 10 rupees question, then go for 1,000 rupees question, then only you have to achieve 1 crore question. So if somebody asks you, can I go direct, can you ask me that directly, that question? I'm not sure if you can achieve that, but probably this. So these are the giants which probably we are standing on their shoulders to make our life easier, because they invest billions of dollars and they release this SAM model just for free so that they democratize AI, and so people like us can use this to automate to a certain level, right? So see, this is very interesting. So they go from assisted manual to semi-automatic and fully automatic. Uh, they would have clearly written down the terms and condition. I think the driver will be responsible. The person was yeah, that is. So yeah, that is something probably the regulators have to challenge them. But they clearly would have told that this is just an assisted mode. Um, But for example, this Waymo now in certain cities in USA, they are completely operating in a fully autonomous mode. And there will be no driver at all. So that's Waymo taxis there, right? San Francisco is there. Yeah. So in that case, Waymo is liable. If it, yeah, if it made any accident and if that person dies, then Waymo is, I think, responsible. But somebody, they are jumping into Waymo for suicide or something. I don't know what is. It's a very tricky area, right? So, so they have to do some proper investigation. They might have some, yeah, they already have some cameras. They would have recorded those videos. They would have done some all those investigation. That's the driver will not have any ownership on that. Yeah, so in that case, if it is proven that it is Waymo's mistake, probably the Waymo company has to take responsibility. What is that? Okay. So that is how they created this data set. And then and cost that we talk about, it's mostly the hardware, right? GPUs or so there is two main cost. One is the training cost. Another is the inference cost. Then the development cost is there. The people involved in it, your data scientists, your data engineers, your data labelers, all this. But mostly the most big chunk of that funding will mostly will be hardware. Yes, in this current LLM era, I think hosting a model and running such 1 billion, 1 trillion parameter model is quite expensive. I heard, I'm not sure if this might be a rumor that recently I think Meta fired 8,000 people. Quoting, they spend $14 billion just for a bill. So probably some AWS bill will come for $14 billion. And that is one of the reason 1.5 year back, Amazon shut down the Amazon Go. Yeah. So therefore, so they realized their infrastructure cost is more and it's not profitable and sustainable to run that. So that's where I think that there is a new area of context engineering. So there's also discussion that once we hit the copilot limit, there is also discussion like how we can train the people to use the copilot effectively. How can they send minimal tokens like that?
It is structured in actually whenever we ask for help, it will take all the five letter code. So for them, they introduce the practical structure of our code. Where it will store all the levels of our code and its neighboring information.
Okay.
So if you ask where is the payment business logic is written, you will immediately grab that instead of going to all the price and gains machine. If we can implement that in our code base, it will be most effective. Like 10% usage, 90% we can function. Larger code.
So then the question should come like, why can't Copilot do this on its own? That is the reason. Okay, anyway, I was just joking. Yeah. Sorry? Oh, really? I don't know. Oh, okay. So then you already lose your token limits. Because then, yeah, yeah, then you are not asking the right question at the first time. That time you already lose to certain token limit. Then it add a follow-up question. Then you lose the limit. So it means if you are not trained to ask the questions in a correct way, it is asking a lot of follow-up question. You are losing your token limit for every question and every answer it generated. Yeah, of course. So every API call, that is a smartness that of the model, but that is the sort of a gap of the user not being able to ask or prompt in the right way, and you are just asking random questions all in all. So sometimes what I do is like I just try to put all my thoughts first in my notebook, and then I try to articulate my question as much as possible, as precise as possible. Not because of this token limit thing, but because it gives me a better answer. Yeah, in one shot. Otherwise, what happens? It goes back and forth, and after fourth question, it gets completely lost. Then I have to again start from scratch. So it's better always try to. Mm, mm. So for syntax error and all, don't call Claude Opus model there. So there will be some very trivial syntax error will be there, right? For that and all, they will call Claude. So then you will lose your tokens. Yeah, your self-hosted models. Yeah, that also we can use. But we didn't foresee this is coming, right? People were assuming that we had some unlimited. to- Probably they realized their cost is. Yeah. See, they projected it in like such that you can use Copilot unlimited, go and generate codes. Just then recently they say we have limits.
Business strategy.
Business.
Get people addicted to it. Like by saying that
Now they are asking us to pay.
group of the spring for and they are saying you want primarily only stocks because of cost efficiency.
Yeah. So this needs little additional training. They should have done this the beginning only.
Yeah.
Yeah. I don't know. Yeah. So this is what is getting trapped actually. Yeah. Yeah. But they are running in $1 billion loss, right? All this OpenAI and I hope so. I'm just they also have a huge infrastructure cost. So and they are giving this all this APIs, right? Some 10 cents or something per API calls or something, right? They are like a very negligible cost. But how will they make profit? So at some point they have to make this decision. Okay. Okay.
Branches with sort of 4.7 that like but they give it 30 that more
Okay.
they give it they hand the chip. That cost itself is reduced.
Yeah. Okay. So this SAM has different versions. So SAM 1, then came SAM. Okay. So we had SAM 1, then SAM 2 came. In SAM 1, it does not support video. In SAM 2, they introduced video support. It could also track objects. So when you segment the objects, and then when you play the video, these objects are get tracked along the video timeline automatically. Okay. So I'm like seriously annoyed with this SAM demo update because earlier it was very easy to use. I think probably they purposefully made it difficult, similar to this Copilot thing. So now also you see they have limitations. So uh, probably next week we'll see if this problem is getting.
We don't have a similar model for object detection. Like you already don't have something.
See, if you have mask, you can very well get the bounding box. So if you can predict it mask so easily, you take the, for example, this one, right? You have this segmentation mask. You can just draw a bounding box around it. It's pretty easy. Yeah.
So we take the mask images and put it to a model.
No need to get bounding box. No, you can get the geometrically you can get the bounding box. No, if you have a polygon coordinates, you take the min and the max. Yeah, you just draw.
So what I'm doing is if I want to word for object detection, I need to create a data set. Right. This image, whatever mask is there, I feed it to a model to get the bounding boxes, and then my job is to be done for thousands of images.
Got it. Yeah. Yeah. You understand. Yeah. Understand. track anything. So what they're saying here is this is a different use case. There's some you can track objects and you can do some specific use cases such as sensitive information detecting, like hiding children's face or number plates blurring, or some sensitive information blurrings. You can do even Photoshop editings, just removing the background. Uh, yeah, I really do not like this updated demo. It's more fancy than anything useful. But yeah, earlier you used to have this link, which is this one, segment anything demo, which is now broken. Okay, this is working, but somehow it's in a dark mode. I'm not able to see the image. Just check on your computer whether it's able to see this image. Okay, anyway, but what I want to say is, and Sam 2, they included video. Then in the recent SAM 3, they included something called open vocabulary, which means until SAM 2, they were not able to search through text prompts. So that's what is given here, that you can just type some objects, right? You can just type some objects like this and then search for the objects. So it will try to search on to the image and it will draw a precise segmentation of those. Okay, so this is through text prompting. Then uh, then there is another capability called image exemplar. Okay, or a visual prompt, which means if there is an image and if you point one instance of that object, it will take that as an image exemplar, which means sort of an example reference, and then it will identify all other instances in the image. Okay, so in our CVAT, I'm not sure if we have SAM 3. I think we have SAM 3. Okay, let's try that. This is better. So I have not tried. I'm just going to try now. So install 1%. Okay, 1 second. So if I call this, yeah, sorry, what's your question? Sam. And rest all it should be the images and include comments. Yeah, we can do within an image, but you can try, but that's not possible with SAM version 1. That's possible with SAM 3.0. So SAM 3.0 is also has the GitHub. So you can clone this repository, set it up. Then they have some example. See, they have different example notebooks, some basic demonstration. Then, yeah, probably they have this image exemplar demonstration also, which means in an image, if you just prompt one object, and if there are 10 more objects same like this, it will identify the remaining 10 objects in the same image. In different image, I have not tried. Probably it can support, you can see. Maybe I will go home and try this. Maybe next week I will update you. So they have SAM3 agent. So use this SAM3 GitHub to explore all these example notebooks. It's worth spending time in SAM3 or at least SAM, okay? So if you ask, should I, okay, I have just limited hours, should I spend learning segment PyTorch that we discussed, or should I learn SAM? I think you should learn SAM instead of that. Okay. Just go home and spend some time going through this repository. Okay. So you have to click this box. That is because you have not created the, but you might have not created the labels, this one. You go to projects, then add labels. Create 2 or 3 labels. Yeah. Strong SAM3. Okay, so while it's generating, I will also take 5 minutes to go through the assignment. So assignment, it has instructions. Okay. So the objective of this assignment is to develop a quality control visual inspection system that can automatically determine if a box of pins is acceptable or should be rejected. Now, how does that image looks like? So it has 5x3 compartments or bins, you call it, and each section has one board pin, push pin. Okay. Um, Ideally, an accepted box should contain one good pin per box, one section. So which means there should be like 15 good pins per box. Okay. Which means I should say, hey, this is one good pin, good pin, good pin, good pin, good pin, good pin. Like that, if I have 15 per image, then this box is accepted. Everything else is rejected. There could be one section that contains 2 pins. Remaining everything has like one pin, but somehow this contain 2 pin. So this means it has to be rejected. Sometimes they get 3 pins. Sometimes there are missing pins. Sometimes there is quality issues. The pins are of not good quality. Although all the 15 compartments has each one pin, but this one pin is bented. So I need to reject this also. And it could be broken. or it could be a wrong color. It is expected that everything has an yellow pin, not a red pin. Or that could be something else other than pin. So here there are some piece of wire or something. Then there should be separator. Sometimes the separator is missing. Okay. So those are the 9 different scenarios or 9 different classes that is possible in this to be detected. Okay. Now the problem is, can we train a model to identify all these 9 scenarios? How to tell, okay, there is 15 good pins and then I'm accepting this box. If not, what is that issue? This box is rejected because there is one compartment is having 2 pin. This box is rejected because there is one 3 pin. This box is rejected because there is a missing pin. There is two missing pins out there. Likewise, you need to come up with some reasons also. We have to tell why we rejected this.
We can combine classes also. There are multiple listeners saying just 2 or 3. We can just use one class, stating that there are multiple.
Yeah, that makes sense. But just for a learning purpose, I'm making it multiple. Okay. See this, whether this assignment makes complete 100% sense, I'm not sure. You can challenge me left and right, but for learning purpose, I made this assignment. It was just a very toy example. Okay. So the data set contains a total of 300 image, and out of that 138 is labeled as good, which means that they all contain each just one good pin. Okay. Remaining 172, there is one or the other issues like 2 pin, 3 pin, broken pin, foreign object, missing separator, like that. So basically, you need to train an object detection model such as YOLO models to build a pipeline that can identify these issues and then accept or reject a box. Okay. And that's it. No, that's not labeled. There was label, but probably if you search in the internet, you might find. But I intentionally removed the label. But it's good that you get some experience on labeling as well. See, for example, how to define a class in the CWAT, how to set up a project in CWAT. Go and create a project, upload all the images, go and define this classes.
Can be
Yes. Then label them. Then how do you export it into the right format so that you can train a YOLO model? So these are the dirty works that we do in order to call ourselves as a data scientist, right? Multi-class.
good and bad. Good and bad for
Which is good and bad?
good box and bad box.
And that is finally, see, you have a multi-class object detection model, but based on that, I will tell whether this box is rejected or accepted. Yeah. So you have a certain product, but for that I have one multi-class. This one you finally say is box is rejected or accepted, but you also tell when it is rejected. You tell a reason why it is rejected. Probably there are, like, I'm just making up some imaginary, like there will be 3 teams. One team is just addressing the missing separator issues. Whatever the box there is missing separator, there will be guys who's going to take this and put this separator inside it. And whenever there is missing pin, there will be 2 guys sitting just putting pins in that simply I'm saying you can categorize, right? Based on the reasons. Yeah. Yeah, that's it for today. Thank you.